Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 10 from the October-November 2023 International A-Level Cambridge 9709 paper 1. This is pure mathematics and this is variant 3, so it's paper 1-3. And this question here is about radian measure. And it says the diagram shows points A, B, and C, which are lying on a circle with center O and radius R. Small r is the radius of the main circle there. Angle AOB is 2.8 radians. The shaded region is bounded by two arcs. Okay, so you got the arc. The upper arc is a part of the circle with center O. So this is an arc of the main circle, this arc AB in the top here. And the lower arc is part of a circle with center C and radius capital R. So this is like a sector of another circle. Okay, so this is the sector of a circle. So this is R. That means this must also be R. And of course, this is small r. Right? So these two triangles, you can see that they're congruent triangles because they have the same length of the sides. All three sides are exactly the same. They're congruent triangles. Okay. Now, so state the size of angle ACO in radians. ACO is this angle over here. Now, a quick way of doing this is to understand and to remember the rule that we learnt in, hopefully in IGCSE, for angles in circles, where you have an angle subtended to the center and an angle subtended to the circumference. And the angle at the center is twice the angle at the circumference. So if this is x, this would be 2x. So that means this angle over here, the angle ACB, say angle ACB, is going to be a half of the angle at the center, which is 2.8 radians. So that means that's going to be 1.4 radians. That is this angle over here. And what we have, because these are congruent triangles that we just mentioned, that this angle ACO, which is what we have to find, ACO is going to be a half of ACB. So that's going to be 0.7 radians. Okay, so in fact, I should have put that work in over here, but I put it in a place where we could see what's happening. Okay, so that gives us the answer. ACO is what we had to find. Let me just make that a bit neater. Is it 0.7? Okay, so that's probably the easiest way of answering this question, using the fact that this angle here is twice the angle over there. So that's going to be 1.4, and that's a half of 1.4. We could have also done it another way. Some people might have found it by thinking about this triangle hat, that these two angles are equal to each other. The whole thing is 2 pi, so we'll have 2 pi minus 2.8 divided by 2. That would be this angle over here. 2 pi minus 2.8 would be the whole of this angle. Divided by 2 would give you that. So that's pi minus 1.4. That would be this angle here. And because this is isosceles, we could say that these two angles both would be equal to 180, which is pi minus 1.4 divided by 2. Okay, because you take away this angle from 180, which is pi, and divide by 2 to find these two angles, because they're both the same. It's isosceles triangle. And as you can see, that's going to give you pi minus pi, which is 0. And you're going to have 1.4 divided by 2, which is 0.7. So whichever way you do it, if you didn't remember this rule of angles in circles, you could do it by using the fact that this is an isosceles triangle, and we can know what this whole angle is. Whichever way you did it, it's fine. It's just worth 1 mark. So that's the angle ACO, 0.7 radians. Now remember, it's in radians, very important. Now, for the next part of the question, it says find capital R in terms of small r. Okay, so we've determined that this angle here is 0.7. And we've also determined by our second method there that this angle is going to be, as we said, pi minus 1.4. Okay, that's pi minus 1.4. Let me make this a bit bigger so we got some space to work with. I'll just write that stuff out again in a minute. Just got a bit more. I want to make it very clear. So we have determined that this angle here is 0.7 radians, and we've determined that the whole of this angle was 2 pi minus 2.8. So half of it is 1 pi minus 1.4. Okay, and this is also 0.7 because it's isosceles. All right, so we're going to find capital R in terms of small r. We can link these angles together using the cosine rule, using the sine rule. The sine rule will probably be easier. So I can say the length r, capital R, over the sine of the angle opposite it, which is pi minus 1.4, is equal to, we have another pair of opposites, small r over the sine of 0.7. Okay, so we can say capital R, therefore, is going to be r times sine of pi minus 1.4 over the sine of 0.7. Now, if you look at the examiner's reports, they mention you should give the answer as, the value of this rounded to certain, 3SF, of course. You've got to give it in terms of, R in terms of, capital R in terms of small r. It's better to write this as a value. It won't be exact, to be rounded, rather than leave it in this form here. So write it as a value, find out what this is, round it to 3SF, and have your answer. We've got sine of, now we've got to make sure we're in radian mode. So I'm going to first do that. So angle unit, 2 radians. We're going to have sine of pi minus 1.4 divided by the sine of 0.7, and that gives us 1.5296. That's 1.5296 R. So I'm going to write it as capital R is equal to 1.53 times small r. Okay, but I'm going to keep this answer. I'm going to store it in case we need it as A. Okay, so that answer is now stored in its exact form as A. So there's the answer to part B. Capital R in terms of small r. All right, that's that question there done now. Now for part C. It says find the area of the shaded region in terms of R. This one's slightly more challenging. It's actually given 7 marks here. All right. So what we got to understand is we have some shapes here. We have to find the shaded region, which is the area between those two, arcs. Okay, between those two arcs. So the big arc, the upper arc, is made up of, or made from, you can say, the circle. That's like this. Let me try and make that a bit neater. Okay, so the big arc is made up of, so this is the big arc, which is this one on the top, is from O and A and B. Okay, it's from O, A, and B. Where here you have 2.8 radians, and that's a big arc. Okay, so if I find the area of this part here, that'll be the area of all of this, basically. Okay, then what I can do is I need to take away this area from that. I need to find what this area is over here. So my next, this area is no problem. This is going to be, we know that the area of a sector is given by the formula half r squared theta, where theta is the angle that makes the sector, and r is the radius. So in this case, we want to find the area in terms of r, so answer will have r in it. So the area of this section here is going to be, let's call it section 1. Is going to be a half times r squared times 2.8, which is going to be 1.4 r squared. That's the area of this whole part here. That's the area of all of this. Now what we need to do is take away from that the area of this part over here. I need to find what this area is for this AOB, for the lower arc, not for the bigger arc, for the lower arc. So for that, what I'm going to do is I'm going to use this angle, okay, which is, as we said, it was 1.4, and this sector. The sector I'm going to use is the sector over here, which is the sector. Now this is now C, and this is A, and this is B. So this is now looking at the lower arc. So this now is 1.4, and this is now capital R. This is the capital R. All right. So in terms of the area, I'll call this area 2 for now. This is going to be a half times capital R squared times the angle 1.4. So that's 0.7 times capital R squared. And now we know capital R squared already is given by this answer over here. So it's 1.5296 times small r squared. So times 1.5296 times small r all squared. The whole thing squared. So let me square this. So if I square this, that gives me 2.3399. So times, and I'm going to multiply it by 0.7 times 0.7. That gives me 1.6379. So that's 1.1.63. Let me just 79579. I'll just write it that much, r squared. So that's the area of what I've called 2. That's the area of basically this part here. Okay, so I've got that's the area of 2. Now what I need to do is I actually need to find what this area is. I need to subtract this area from the main area here. Okay, so basically if I can find what this area is, I'm going to call it area 3. Now area 3 is going to be basically equal to area 2 minus the area of these two triangles, minus 2 times, let's say, the triangle AOC. Okay, the 2 times the area of the triangle AOC. Why? Because these two triangles are congruent. So I can find the area of one of these triangles, multiply by 2, take it away from the whole of the area I just found, which is this, then that will leave me with this small area here, and then I need to subtract that from the main area, the top. So I have my area 2, which is 1.63979 r squared minus now the area of one of these triangles. Now the area of this triangle can be found using the fact that this angle here is, as we said, pi minus 1.4. Okay, we talked about that before. The whole thing is 2 pi minus 2.8 divided by 2 pi minus 1.4. So I can use the fact that the area of a triangle is given by a half r squared, or half times AB sine C. Okay, so in this case, we have these two sides and the angle between them. So a half times r times the sine of the angle. So I'm going to have 2 times a half times r squared times the sine of the angle, which is pi minus 1.4. That will give us the area, what I've called area 3. Okay, so let me just put that in my calculator as well. So it's minus, okay, and I'm going to have this, these will cancel out anyway. Those will cancel out. So I'm going to have basically sine of pi minus 1.4. So sine of, pi minus 1.4, close the bracket. Okay, that will give us 0.6525 r squared. And now what I have to do is I can say that the area that we need, the area required, is equal to the area of 1 minus the area of 3. So it's the area of 1, which is 1.4 r squared, minus the answer that we find, 0.6525 r squared, and that should be our answer. So I'm going to do 1.4 minus our last answer, which gives us 0.7474. 0.7474 goes on 3SF. So that's r squared, by the way, 0.747 r squared. So that's the area that we're looking for. Okay, so it's a bit tricky. Basically, you have to find what this small area is here, take it away from the area of this sector. The area of the sector is 1.4 r squared. To find this small area here, we had to find the area of this sector, take away these two triangles. There could be other ways of doing it. I mean, for example, I could have found, I guess, the area of this, maybe the whole circle, minus the area of this. So it will be a bit different. I think this is the easiest way. There probably are other ways. I'm sure there are other ways of doing it, but I think this is the easiest way from what I could see. So there's the answer to part C of this question. Other questions from this particular paper can be found by clicking on the link at the end of the video over here. Other questions to do with radian measure of P1 Cambridge 9709 syllabus can be found in the playlist over here. You can look at my Radian measure questions from Edexcel questions. You might find some of them are useful, and I'll put the link for them over there. Okay, and you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.